Okay, good afternoon, good morning, good evening, good night, depending on when you're watching this video. This is going to be a walkthrough of the second summary exercise on working with binomial random variables. This is slide 28 of lecture set number 4. Okay, in this problem, we have in August of 2022, the unemployment rate for persons aged 15 to 24 across Canada was 9.9%. Part A, for one randomly selected Canadian between 15 and 24 years old, what is that probability that person is not employed? All right, so this is simply the probability given to us in the first question. So probability person aged 15 to 24 is unemployed, is unemployed equals 0.099. Herein, we say let P equal 0.099. In part B, it says, suppose you collect a simple random sample of 10 Canadians between 15 and 24 years old. What is the probability that all 10 are employed? Okay, so what we're going to do here is we're going to say, let X count number of unemployed Canadians aged 15 to 24. Okay, so capital X is a random variable counting the number of Canadians in this age group that are unemployed. So X can take on one of two values. So the situation is that a Canadian in the sample can be either employed or unemployed. That makes this a binomial problem where X is counting the number of people that either meet the unemployed criteria or do not. All right. So we want to know in a sample of 10, how many are employed. So we have N is equal to 10, and we have P equals 0.099, represents the number that are unemployed. Okay, so the probability employed is equal to 1 minus 0.099, which is 0.901. Okay. So if we want to compute the probability that all 10 people in this sample are employed, we have probability. Well, we can do this two ways. If we let X count the number of unemployed Canadians, this would be probability X equals 0 is 10 choose 0, 0.099 to the 0, 1 minus 0.099 to the 10. Okay, so if we do it that way, we end up with 0.353. Okay, so 35.3% of Canadians, the probability that all 10 Canadians are employed is 35.3%. So the probability all 10 Canadians are employed is 35.3%. Now, the other way you could do it is you can flip the problem. So you can say, all right, I have the probability they're employed, which is 0.901. So if I let X count the number of employed Canadians, okay, I would end up with the following. Okay, so let P of, we'll call it Y equals 10 equals 10 choose 10, 0.901 to the 10, 1 minus 0.901 to the 10 minus 0. And this thing, when you work it out, is going to give you the exact same answer, where Y counts number of employed Canadians, right? So in this problem, or in the setup for this problem, we have the probability of unemployment is 0.099. But in part B, we're asked, what is the probability that 10 are employed? So we can either flip the probability and set this up as a binomial problem where we count 10 out of 10 successes, so 10 out of 10 people being employed, and use the probability of the individual being employed, which is 0.901. Or we can leave this in terms of unemployment. And if we want 10 people to be employed, that means that 0 are unemployed. And then we can use directly the notation that we established at the start of part B. But either way, you end up with the same answer. Okay, for the SRS collected in B, what is the probability that 0 are unemployed? All right, well, if we do this, so the probability that 0 people are unemployed is the same thing. Okay, so we want C, probability zero people are unemployed. Okay, so the probability 0 people are unemployed. This is the exact same thing as the probability that everyone is employed, at least in the context that I'm interpreting it. Okay. So this would be the probability that X is equal to 0 in terms of unemployment. So this is the same thing as what was given. Okay, sorry if there was a little bit of a cutout there. So the probability 0 people are unemployed. If X counts the number of unemployed people, this is the probability X equals 0. So we're actually asking the same thing as what is the probability that all 10 are employed? So we have X is equal to 0. So then we have 10 choose 0, 0.099 to the 0, 1 minus 0.099 to the 10. And that again gives us 0.353. Okay, so we could say the probability that 10 people or that 0 people are unemployed is 35.3%. Okay. In D, it says, what is the probability that at least one person is employed? Okay, so in this situation, we want the probability at least one person is employed. So it would be easier to use Y, which counts the number of employed people, to set this problem up. So we have Y is greater than or equal to 1, where 1 counts the number of employed persons. So this is going to be 1 minus the probability that Y is equal to 0. So now we have 1 minus 10 choose 0, 0.901 to the 0, 1 minus 0.901 to the 10, minus 0. Okay. And this is going to give us ,1 minus 0 or 9.044 times 10 to the negative 11, which is approximately 1.000. So the probability at least one person is employed is approximately 100%. Okay. Okay, in E, for the SRS collected in B, how many people would you expect to be unemployed? Okay, so the expected value of X, which counts the number of unemployed persons, is equal to the mean of X, which is N times P. So this is 10 times 0.099, which is 0.99. So we would expect 0.99 persons to be unemployed. All right. So these are several or three other illustrations of using the binomial probability formula in different contexts. One more illustration of computing the expected value. And then we also had a bit of a setup question where we determine the probability of being unemployed given above here. And then we can use this in different situations to compute the other probabilities that are of interest to us in the binomial context, depending on our interpretation or how we want to set up the problem. So we have the probability of people being unemployed. So we let X count the number of unemployed people. But given that we were in some cases asking about probabilities of employment, it's easy to just use the complement of P and use another random variable, say capital Y, to count the number of employed persons, and then use our binomial probability formula in those contexts. Okay, as always, if you have any other questions, please let me know.